In this tutorial, I will show you how you can duplicate duplicators in Cavalry. Duplicating shapes in Cavalry is super easy. We can use Duplicator and just populate it in any of these modes. However, if you want to create a custom mode like this one, for example, to stack your shapes in a perfect triangle way, you have to use two duplicators to achieve this result. Now let's have a quick look at dependency graph, what is going on. So let's ignore all of these extra nodes here and focus on these two nodes. These two nodes represent duplicators. And starting from left, this duplicator is feeding all sorts of information that flows all the way to the second duplicator. And we're using information represented by this line over here to influence how the first duplicator is creating shapes. So this might be a little bit confusing, but hopefully I'll be able to explain to you what is going on in a second. Essentially, we are using information from the second duplicator to create shapes in a specific way in the first duplicator without creating a feedback loop which would prevent us to make certain connections. So let's start with a simple scene. Going to create a simple polygon shape, change the sides to 3 and leave everything as it is. And I will need to create bounding box node, drop the triangle into the input shape, I'm spawning it like this. So we have dimensions of the bounding box of this shape. Now I'm going to put this shape into a duplicator and switch the mode to linear. Next, let's switch it to step and leave it at the horizontal setting. Then let's rename this duplicator to rows. Then I'm going to add a math node to the size, spin it here, and I'm going to grab the width of the bounding box, drop it here in the first field, switch it to add, and this way I can easily control the spacing between these shapes. Going to keep it at 0 for now. Next, we need to put this duplicator into another duplicator. I'm going to rename it to triangle. Then I'm going to use sort distribution mode and switch it to linear. Pick the direction as horizontal, change the size mode to step. So what is going on? We have duplicator, the first one, creating individual rows, and the second one instancing them from top to bottom. I'm using the sort mode so I can easily reverse the way these shapes are stacked on top of each other. This will make more sense if you look at the indexes. If I click this button, they flip and 0 is on the bottom. So next, I'm going to add a math node to the size. And as before, let's switch it to add. I'm going to use the data from the bounding box, this time height, to perfectly space out each row so they are stacked on top of each other. So we have two controllers. We can easily create gaps either on the side or on the top and bottom, but I will keep it at 0 for now. Okay, at this point, there is nothing special going on. Essentially, we created a complicated grid distribution like this one. So we want to use data from the second duplicator, the triangle, to influence how the first duplicator behaves per each row. So the way we're gonna do this is by adding math node to the count field over here. Then I'm going to go to second duplicator, go to the advanced tab and grab the index context and drop it on the second field. And as you can see, everything changed. So essentially what is happening at this stage is that we are using the data from a second duplicator, the index data, and feeding it back into the first duplicator. And since indexes in Cavalry are starting from 0, this means this first row is not created at all, but I have index over here. So to fix that, I'm going to add expression. value +1, and this field will essentially control how many shapes we are starting from. So at this point, we're starting from 1, we can change it to 3, and so on and so on. So each row will have more shapes than the other one. Essentially, we are multiplying, in this case, 3 by 1. This results in 3 shapes. Second row is multiplied by 2 because remember we offset the index number. So now this index is at 2 and this one is at 3. So 3 times 2, that's 6. And again, 3 times 3, that's 9. Gonna keep it at 1 for now. Go back to the triangle duplicator shape. And since we use the sort mode, I can easily reverse the distribution. I'm going to add a line modifier and push everything up so the pivot point is at the bottom of this shape. And this way, when I increase the count number, everything grows up like a pyramid. And the best part about this setup is that everything is linked with math node. Essentially, we are using the dimensions of this polygon shaped triangle. So if I change the dimensions of the polygon, everything resizes like you can see on the screen. And I can increase the copies. And this can be controlled independently using these nodes. For example, the math count node, we can start with, for example, 3 copies like this. It all depends on your design. Going to change it to 10 for now. So essentially, we created a custom distribution mode using 2 duplicators. And let's have a look how this looks on the dependency graph. So this is a little bit clearer than the first example I've shown you because we don't have extra nodes that control the color and animation. But we have initial polygon shape that goes into the first duplicator, and data from this polygon shape goes into bounding box, which we use to control the distribution size, how the shapes are spaced out on the vertical and horizontal. Now this line is the most important one. The one goes from index context back to the math node, and this feeds into the distribution count number because this line influences how many copies we get per row, and this results in this pyramid setup. So let's have a look at the second example. I have exactly the same composition as before, but I will make some changes. Instead of using math node in here, going to delete it for now, I'm going to add an array. And we have 10 copies. Let's just switch this to something smaller like 7 for now. So I need to create 6 more fields in the array. And now when I populate this array with random numbers, the whole thing updates. Maybe this one's a little bit too big. So as you can see, we don't always have to use the index context data from the second duplicator in the first one, but we can use an array to specify how many copies are created per each row. So this is super useful if you are working, for example, on some sort of organizational chart and you need to create X amount of fields to visualize employees and so on and so on. Now in this demo scene, I have exactly the same setup as I've shown you at the very beginning, except it contains few extra nodes to change the color and a couple of keyframes for the animation. I ended up using JS math nodes, but they are doing exactly the same calculation as before, which is multiplication of a starting value and index context from the top duplicator. The only difference in this setup is instead of using a single math node to calculate the size between each row, I'm multiplying the gap by the index number of each row to simply increase the distances between squares. And at the end, I can easily animate this to create the following animation. And in this example, we have a grid distribution. However, it's made of two duplicators, both are set to linear, as you can see. But what's so special about this is that I'm using duplicated data to change the corner radius of each copy. So if you look closely, the very first one has no corner radius, is sharp, and as we get more and more copies, it keeps rounding up the rectangle until it becomes a perfect circle. And I got this effect by simply using math node on the corner radius, which contains a second math node, which simply multiplies the index context of the second duplicator by a value of 5. I can increase it to influence how quickly the transformation from rectangle to a circle happens. So now you can see how you can use data from one duplicator to either influence the underlying graphic or create custom distributions of your own. If you want to see the whole project file, you'll be able to download it from Gumroad store for a small donation. Thanks for watching.